This study of geometry involves gathering information outside the school and analysing it in the classroom. Year 9s from Wilden School in Hampshire are looking for maths in their local children's playground.
There's like a triangle underneath.
It's like the gradient.
Yeah. Half a circle.
Half a circle.
With them are maths teacher Debbie Johnson, advanced skills teacher Natasha Cowan, and their IT technician to take pictures with his video camera.
The project aim was really to make the mathematics memorable for the pupils by putting it into a context and give them a very real opportunity to work with some of the mathematics that we find around us.
Well, I'm seeing 360 degrees a lot.
That they were split equally in thirds and the angles were 120 degrees each because the circle's 360.
It's like a dip type, it's like a half a circle.
A group of pupils out of the class going into a playground situation and looking for all the mathematics that they could see. And they were recording that through taking photographs, through taking measurements that they could bring back to the classroom.
So how tall's the whole of that?
2 metres 23.
So what maths are you looking for?
The angles and the it's a triangle. Angle of the slope.
Do you remember what the word for that is?
Gradient.
Fantastic.
The circumference round the circle, and like when it goes up and down, the distance between, I don't know.
The circumference of the circle that we were going in and the radius that was between us.
Oh.
OK, guys, so what measurements might you want to take back to school from this?
The diameter.
The diameter.
Circumference.
The circumference. Do you need to measure the circumference?
No, you can work it out.
How could you work it out?
Pi times diameter.
Excellent. So
Or
if you
pi
measure
times radius squared. No, pi times radius times 2.
for the circumference.
Oh, yeah.
The speed on the sides is a lot slower because obviously you come off quite a lot of.
Is the speed a lot slower? Do you agree?
If what Josh said about coming off quicker at the sides, then it would probably be faster.
So it might be faster, you think, around the circumference than in the middle. So what mathematics could we find to do with this swing, girls?
You could find like the arc of the swing.
Yeah.
And then work out the whole of the circle and like work out the radius and
Work out the radius.
The radius. Where would you go to measure the radius then? How would you do that?
You'd need to go from the top here to the middle
bulge.
bit of the circle.
Okay, so you're going to measure from the top to the middle bit of your swing. So just talk to me about the shape that you're actually sitting in.
it's like a dome, so you could...
Like a dome, okay. Do you know what the mathematical name is for a dome? Part of what shape?
A sphere.
A sphere. I think as a class teacher, you feel it's risky to do this sort of work. You're putting the learning in their hands, and that's quite a brave step. It is extremely rewarding in terms of looking at what you get back. You never fail to be surprised. Do you open it with? Oh, okay.
Back at school, they download the pictures taken in the playground and begin to explore the mathematics they suggest.
We're just looking at pictures and seeing what maths we can come up, so like gradient. So if we can see different gradients and circumference. So we can put that into geometry sketchpad and make that into a circle. Find the radius. Yeah, well, do you want to do it?
Once the pictures are in the dynamic geometry software, students can add lines and shapes over them and measure lengths and angles.
Well, it's a semicircle.
Is it?
Yeah.
How are you sure it's a semicircle?
It's half of a circle.
Could you show me that?
Yeah, because I could draw a line from there to there.
They were then able to decide within each group a focus that they were going to look at for their project. And starting, most importantly, to share ideas, overcome problems. Is it a semicircle? Then you're going to think about now how you're going to find out and answer that question.
So the think card should be measure the distance from where the swing goes back to when the swing goes forward.
Yeah,
To measure the distance it travels.
yeah, that'll work. Do you want to write it down?
You can write it if you want.
Okay.
You've dropped your picture into Geometer Sketchpad. What are you doing now? Because it looks quite interesting.
So we've just started measuring the lengths of our points so that then we can times them together to get the gradient.
Do we times them?
Divide them.
Divide them. Oh, so what? So you've drawn some lines here
Yeah.
to make it. What have you made it into?
Well, we've made it a right-angled triangle.
Okay.
Relative to the angle of the slide.
Okay, and that's quite a good fit for this slide, isn't it?
Yeah,
That's quite good.
It worked quite well, yeah.
Okay.
It's quite good to experiment with like the different tools and stuff on Geometer Sketchpad, and it's quite good the way you can measure like the lines, gradients and stuff using the information you collected at the playground.
It's a picture of a big slide, and we've just like put in some lines to show where the triangles are. We've got to calculate like the size of each triangle so that we can eventually find out the length of this slide.
You need to find out the diameter. Click on the line and then go length.
They're computer literate and they're used to using ICT as a learning medium.
Yeah, that'll do. And then you need to measure that. That should be half of that.
They see that very much as a tool that they can use.
We got the picture of the roundabout, but
Yeah.
it's slightly disorientated, so
What do you mean by disorientated?
like it's an angle instead of having like a bird's eye view on it.
Ah,
So-
okay. So it's a bit distorted. It's not
Yeah,
quite
distorted, that's
okay, as you'd see it from the top. Does that matter?
Yes, because
When they're thinking through the project, it's actually very structured in terms of setting the context for the investigation, thinking carefully about your groups, how you're going to encourage the pupils to focus on the mathematics they're going to do, how you're going to encourage them to keep going, the key questions that you're going to ask, that's crucial, really, and learning not to answer them yourself, but to pass them back as a question. What type of triangle is that then, if you've got
scalene.
a scalene triangle, okay, and do you think that's really, is that what you expected?
Not really.
No, not really.
What did you expect?
I think kind of an isosceles, maybe.
Okay, and why do you think? Is there any reason why you think you're not getting what you expected?
Because it's at an angle.
Because
not,
it's at an angle. So, okay, so what can you do?
we
You're
can
going to do your plan.
do our own circle.
Okay.
What we were trying to do is work out the radius of the thing, of the
thing.
swing.
Okay, why, can I, just stop a minute and explain to me why you were finding the radius, because I'm interested in that.
What we were trying to do is work out the circumference of the circle if it was to go round.
If it gone round the whole 360.
Okay, and why do you think it's a circle? Explain to me a little bit about that. What's happening?
The swing.
Yeah, I can see.
It goes in a 180-degree angle. Well, if it's swung to the top.
It's like an arc. And
Okay.
the arc
Yeah.
is a little bit of a circle.
Okay, and it might go. You're saying to me it might go.
Hot, yeah.
Okay.
halfway.
The only thing is, we didn't get the length of that at the park.
Oh no. Okay, so we've got the scale, but we haven't got the real length.
Yeah.
Okay, what could we do? We're in the classroom, we can't go back to the park.
Yeah.
Is there anything that we could do to try and think about what that real length might be?
Could you try and estimate it?
I think that's the best we can do now. What could we use to help us with our estimate?
How tall?
There's somebody in the picture, thank goodness for that, because that gives us something. Now, so how could we use Chloe's height there to start to help us to think about the real radius?
Like, we could take my height
Yeah,
and then see the difference
okay.
between what it is in the picture
Okay.
and then what it is in real life,
Okay.
and then somehow
Do you know how tall you are?
about 5'5". I
Okay,
think.
are you going to work in imperial or are you going to work in metric? Do you going to work in feet and inches or are you going to work in metres and centimetres? Okay, you've got your scale drawing in centimetres, so that might make life easier. So I think, what do you need to do before you can do anything else then?
Work out the length.
Of
Chloe.
Of Chloe. We need to find Chloe's height in metres and centimetres, or in centimetres.
I think two of the key learning skills that students are developing through this project Worse Than These Tasks would be the creative thinking and independent learning. The students are investigating their own routes through the project and their own tasks. They are having to think about exactly how they're going to take that route and why and what else they could investigate. But also the independent learning. They are working on their own and they're choosing their own decisions as they go.
Our question was whether this playground toy here was a semicircle, and what we did is we dropped it into Geometer's sketch pad and we drew one of our own circles around it, and then we could tell the scale of the picture, because we asked her what height she was. She said 5'3", so we knew there was
The height of the...
we knew there was 12 inches in a foot, so we did that calculation. And then in this picture, Jodie's height is 8.48 centimetres.
Which is nearly the height of the middle bit.
Yeah, which is almost the height of this bit here.
Well, we decided to see what the triangle actually was. We just did a circle. We're not sure if it's like the exact same size, but we just did a circle, and then we constructed a line, transformed and rotated it 120 degrees because we wanted to get 3 equal parts, and that would create 3 equal parts for us. Then we just joined up all the edges like we did there, just on here, and we got it was an equilateral triangle. And now we're going to work out the circumference of that and write down the circumference of the actual roundabout.
We did Pythagoras' theorem to work out the hypotenuse of it. So, and then we managed to check it by using measure, and so we successfully did that. And we get to use investigation, and instead of just getting normal textbooks out, we can do it actively.
We can work in groups and be able to explore different things of our own choice.
Normally we're doing like questions in books and stuff, but doing this is more active and more fun. Whereas like doing books sometimes it gets boring. We get to be like much more open with what we do, because we get to like make our own actual like question card, and we can investigate something like we choose ourselves, so we can go even more deep into things, and then maybe once we've done that we could expand on what we've done even more. So it's almost like a starting point, and then you're it's like a spider diagram, and then you're expanding out different ideas.
So when you're finding things out on your own, you like kind of taking the information easier. Whereas when you're sat in a classroom just listening to the teacher talk, you kind of get distracted easily and the lessons aren't as fun. And so this way you kind of find the information out yourself and kind of remember it more for the future.
I've learnt how maths applies in the playground, and how it is more important than people think.
And how if you look, you can actually find maths anywhere, even like, because you never before, I've been to that park we went to about 5 times, like 20 times, and I've never seen the maths I see now.
We want to encourage pupils to see mathematics in everything, in everyday life, and to use their mathematics and their problem-solving skills as they grow and as they work and learn. And when I analysed the mock results, there was a question on the higher paper about find the arc length, and they all got it absolutely correct. And I know because they spoke to me afterwards and said there was a question about the swing on the paper, and it had made the maths memorable.